Hi everyone, in this video I'll be going over Lab 5, Mammalian Cell Culture. As you might guess, in this lab you will begin culture mammalian cells. In this class, however, we will assume that none of you have had previous cell culture experience. Therefore, for examinations, you will be tested on the material taught to you in section and through posted videos. That being said, if you haven't done so already, please view the 2 videos that I've posted online. If you have any questions about the techniques outlined in the video, you should bring them to your TA during your section. One thing I want to emphasize is that there's a lot of pre-lab reading, and you actually need to read all of it. I'm not going to go through all of it because it'll be boring to hear me just read off it, but there are a lot of really important minor details in here that you should be aware of during cell culture. And for the rest of this video, I'm going to assume that you have read it and make reference to these things. So if you haven't done so already, go ahead and read it. Okay, now I'm assuming you've all read it. And one thing I do want to say in person is that you'll be culturing 3T3 fibroblasts in this lab. You can read more about these cells here, but what I really wanted to point out is that there are a lot of different cell lines and different cells out there, and each has their own kind of peculiarities and different needs in terms of culture, and they're also useful for different research subjects. So as you're doing all the experiments that follow with cell culture, just keep in mind that although you're learning a base set of techniques, not all cells can be treated the same way. Kind of along the same lines, these particular cells you're using are classified as biosafety level 1. This means that they're not actually biohazardous waste. However, EH&S likes for us to take extra precaution with these cells and just cells in general, and so we're going to treat them as BSL2. This is relevant because many of you will be going on to culture BSL2 cells. So it's good for you to learn the practices associated with taking care of them, such as waste management, proper disposal, and so forth. So it's a good time for you to go ahead and review your waste management training prior to this lab as well. So since this is going to be the first time for many of you that will be doing cell culture, we're going to expect that this procedure is going to take you guys a little longer than you might anticipate. But by the end of this course, you should be able to finish passaging cells within 30 to 45 minutes. So to start, you're going to be making media. Your media is going to be pre-warmed for you for the most part in this lab, but just keep in mind that that's not really the case in a real lab situation, and that's one of those minor details that having your media at the right temperature is important for optimal cell growth. After you finish making your media, you're going to be given a flask, and you're going to be asked to passage this flask into a 6-well plate and a T25. You should calculate beforehand the amount of cells you need to place into each well in order to reach the densities that are described here. So, because you already have that video that Arshia and Messiah have worked on, I'm not going to belabor the exact details of how to perform cell culture. What I do want to kind of point out is that there are a few steps you really need to pay attention to. So, in particular, Step 6 through 8, which describe the rinsing step. As it mentioned in step 8, really the point of this is to kind of remove factors that might influence your dissociation process. And this is going to be primarily getting rid of calcium and magnesium or other ions that promote binding of cells to surfaces, and removing inhibitors of trypsin, which is the protein we're using to cleave the cells off the flask. In addition, one kind of small detail is that you're going to be spinning these cells at 150 xg. This unit xg is synonymous with the unit RCF, and it's a reference to the amount of force cells feel or an object feels in the centrifuge. I'm sorry, but there's actually a mistake here. This 2500 RPM is not correct. This is from our old protocols, and I actually have no idea why it says 2500. But when it says RPM, it refers to how fast the actual rotor inside is spinning. And as you might guess, that the actual force that a object that is spinning feels is dependent on the radius as well. So that's why 150 xg can have different RPM value for different machines. And your TA will go over this in section with you guys. One last thing that I do want to point out is that when you're aspirating media when you've pelleted your cells, you need to be really careful at this part. And the kind of procedure I've included here, which is to aspirate the supernatant, you kind of tilt your flask, or sorry, you tilt your vial, and then you very slowly go in with your aspirator. This is kind of more a suggestion. This is what I personally do. And if you want to be shown how to do this, you can ask your TAs. All right, so to help you guys out with your cell culture, I've included some references here. I have the surface area, how much trypsin, and how much media you should be using for the different kind of cell culture surfaces you're going to be seeing, such as a 6-well plate, a 24-well plate, and a 96-well plate, a T25, and a T75, as well as how to label things. So that's everything. I'll see you guys next time.